we are given an integer array lambs and an integer val. Then remove all occurrence of the vowels in lambs in place. The relative order of the elements may be changed. Since it is impossible to change the length of the array in some language, you must instead have the result be placed in the first part of the array length. More formally, if there are k elements after removing the duplicates, then the first k element of the length should hold the final result. It doesn't matter what you will leave beyond the first element after return k, after we place the final result in the first k slot of the length. And don't allocate extra space for another array. You must do this by modifying the input array in place with O of 1 extra memory space complexity. The problem statement clearly asks us to modify the array in place, and it also said that the element beyond the new length of the array can be anything like underscore. Since this question asking us to remove all elements of the given value in place, we have to handle it with O of 1 extra space. Consider the element to be removed as non-existent, just in a single pass. If we keep copying the visible element in place, that should solve this problem. We can keep two pointers, I and j. Well, I is the slower runner pointer for writer, and j is the faster runner pointer for read. So the algorithm is when length at j equals to the given value, skip the element by incrementing I. As long as the length at j not equal to val, we can copy the element j to length at I and increment both indexes at the same time. Repeat the process until I reaches the end of the array and the new length is I. Assume that array has a total of n elements and both I and j traverse at most two times n steps. So the time complexity is O of n. Let's try to implement the algorithm to a Java class solution and define a function remove element self length is an integer list and val is an integer and return an integer 2 and I initialize to 0 and for j is a pointer in the range from 0 from the first one to the last one length, and inside for loop is if length at j not equal to val. That means we can directly copy from the point j to the I, length at j, copy that, and I increment 1 and return, because we just finished. There's if there is else, it is if names at I equal to val, then it will directly skip. So we just finished. We can print solution dot remove and remove element, which can just get the input data to it to test. Yeah, it's 5, and we can do more time. Another two pointers approach is to move all the occurrences of this element to the end of the array when the element to remove is rare, so we can take advantage of this. Now consider the case where the array contains few elements to move. For example, length equal to 1, 2, 3, 5, 4, and the var is equal to 4. So the previous algorithm will do unnecessary copy operation of the first 4 elements. Another example is the lambs equal to 4, 1, 2, 3, 5, and the val is 4. It seems unnecessary to move element 1, 2, 3, 5 on one step left, so the order of the element can be changed. So how can we realize this algorithm? When we encounter lambs at I is val, we can swap the current element out with the last element and dispose the last one. So this essentially reduces the array size by 1. The last element that was swapped in could be the value you want to remove itself, but don't worry, in the next iteration we will check this element. So both I and n are travels at most n steps. So in this approach, the number of assignment operation is equal to the number of elements to remove. So this is more efficient if the elements to remove are very rare. So the time complexity is still O of n. Let's try to achieve this in the Python. First, we need initialize I is start from 0 and n is start from the end, the length of the lambs, and while I less than n means when they before they meet, because I is increment and n is decrement. If lambs at I is equal to val, that means we need to move it to the end, to the last lambs lambs at n minus 1. This is the last one, and if the last point n is used, then it's decrement by 1, so it go from the right to the left, and else I increment 1, so I go to the left, from the left to the right, and then return n. So here we go, we are done. We can print to test the result. Oh, it's right, it's correct. So here we go, we're done.